Even today, halogen bulbs are still used in millions of lights around the world. You can find them in cars, workshops, homes, and factories. They are not LEDs, not gas lamps, and not lasers. They work through a simple but clever halogen cycle. Since the mid-20th century, halogen bulbs have been seen as basic, affordable parts, but this small yellow-white bulb, it has stayed useful for decades. The main raw material is tungsten wire. It is only slightly thicker than a human hair, yet it can survive extremely high temperatures. Long coils must be cut first. So the first step is cutting it into short pieces about 3 centimeters long. That length fits the sealed end of the bulb. To keep production fast and consistent, the factory uses a fully automated CNC production line. Here, 2 tiny wires are joined together. Once the contact section is aligned, then a pneumatic device pushes the piece forward. Toward the quartz glass tube above it, the 2 separate wires are now held firmly in place. Beside the line is a vision inspection system. Freshly assembled bulb parts move directly past the camera. The system compares each image with a stored standard. It checks whether every part's length stays within the allowed range. The pass rate on this line is very high because the process removes most human error. The next stage is assembling the tungsten parts. More precisely, this part connects the bulb body to the base. When pressed down, it springs back slightly. This is one of the key details inside a halogen bulb. Now we reach the part most people recognize. That is the filament, compared with a normal incandescent bulb. A halogen filament is shorter, thicker, and more compact. That compact shape helps concentrate the light source and allows the bulb to work under higher gas pressure. Does that make it brighter?
Yes.
It can be much brighter. With the right outer coating, the light can look warmer or more focused. Now, the glass tube. As the outer shell of the halogen bulb, this is not ordinary household glass. It is clear, heat-resistant quartz glass. First, a laser cuts the small tube about 1 centimeter wide into short pieces, roughly 5 centimeters long. Next, each piece is placed into a heat-resistant ceramic holder. The narrow slot holds 1 glass tube at a time. Then comes a key step: heating. As you can see, each glass piece pauses for about 2 seconds. After that, it moves forward. These 4 burners give the tube about 8 seconds of heat. This softens the quartz around the wire and lock the connection into the lower tube. At this point, it is still semi-finished. But the seal lets the lamp body be lifted without pulling the wire out of position. Even under handling force, the glass tube stays protected. The parts can also be heated again to burn off tiny impurities. A camera checks the tube and sealed body. Only crack-free parts or open gaps. Can the part move to final assembly? First, the tungsten filament is placed into the front fixture. Then the glass tube is clamped precisely. How precise is this step? The vertical error is kept below 0.1 millimeter. That accuracy lets heating begin without adjustment. Watch closely. This is a circular indexing production line. The front section lowers the tube. The rear aligns it with the flame. Once the heat is centered, the parts are pressed together. And now we have the first recognizable shape of a halogen bulb. But how does the factory check the heating process? The filament. For that, an exhaust test is used. You can see The moment the bulb touches the probe, it lights up. It needs the right sealed gas. Once the air has been removed, the next step is gas filling and sealing. First, the bulb enters the filling station as it rotates. Gas mixture is added. Notice one detail. The cup below rotates only during gas filling. You may wonder, why the tube? Turns so many times in this station. Filling takes several steps. The rotation helps the mixture spread evenly. It keeps the inside atmosphere stable. This is especially important for halogen compounds. They must be distributed evenly inside the tube. It moves forward, rotates it once, then moves and rotates again. This evens the mixture. Also, most halogen bulbs contain more than one gas. They often use nitrogen or argon, while higher-end bulbs may use xenon. The halogen compound itself is only a small portion. It is not most of the gas. Pure halogen is too reactive. If too much were added, it could damage the bulb, so remember this. A halogen bulb is complex. Most of the fill is inert gas, such as argon or xenon. Now this quick flash of light shows a worker checking the tungsten filament. He holds the test instrument under each bulb tube one by one. A steady blue glow. It means the bulb has passed this basic performance check. To make installation easier later, the factory also attaches a small metal plate. This notched shape guides vertical insertion. As you can see, when lifted slightly, the separate parts lock neatly into place. Is it ready to use now? Not quite. It still needs the final base. The final base moves in. It is worth noting, fixing the base to the tube requires a very controlled process, likely laser welding. That method is suitable. The metal is very thin, even a small weakness. Vibration breaks it after that. A coating is applied to the bulb tip. This dark paste-like material helps reduce glare. It shapes the beam. Avoid blinding drivers. The bulb is almost finished. It is worth noting that spraying and sintering are cost-effective coating methods after a short bake. The loose coating sets firmly onto the glass. Next comes marking. Origin, model information, and brightness details are printed on the surface. Some factories engrave the origin directly. Instead of only printing it, it becomes traceable. Take a look. With one quick turn, the smooth glass surface now carries all the required information. Now we reach the final inspection. The factory checks that earlier heat has not damaged the glass tube. It also checks whether the base installation has caused any poor electrical contact. The chance of failure is very small, but workers still check it daily before the bulbs leave the line. So how is a halogen bulb installed in a car? Halogen bulbs are easy to replace, and that is true. First, unbox it, then open the hood and find the headlight assembly. In many vehicles, it pushes in within seconds. The debate is not installation, it is brightness and color, and beam quality debated for years.